We said we're going to do 5.1 to 5.3. We're going to put both of them together. So this is what you should have filled out the other day. Okay, the perpendicular bisector is a segment, or a perpendicular segment, right? A perpendicular segment Okay, perpendicular bisector is something that is perpendicular and bisects. So it's a perpendicular segment that intersects the segment at its midpoint. Okay, or is perpendicular to a segment at its midpoint. Anything like that. The angle bisector is a segment, line, or ray
So perpendicular bisector bisects like
a
line,
side. It has to be a segment, but yeah. Okay, the angle bisector is the segment, line, or ray that cuts an angle in half. So you should be checking to make sure you have all this right, because this is what you submitted the other day. The perpendicular bisector theorem said that if a point lies on the perpendicular bisector of a segment, then what? Good. It is equidistant.
Is this the same as the stuff on the Quizlet? Because that's where I got it from.
Yep.
Are we gonna have to let's say it asks us a question, are we gonna have to so what are the theorems gonna be the answers to any of the questions?
A fill in the blank question would be like the circumcenters lie in, on, or out, like that kind of the thing. Or the point where the perpendicular bisectors meet is called the circumcenter, that kind of thing. It's not going to be like define an angle bisector and then a line.
We have choices to exist,
for in, on, out. No, it could just be a blank. You don't have to have it. Yeah. All right, then the converse of the perpendicular bisector theorem said if a point, that should be a point, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector. The angle bisector theorem says if a point lies on the bisector of an angle, it is what? Equidistant from what?
From the sides of the angle.
Good. And the converse to that says if a point is equidistant from the sides of the angle.
Then it's on the bisector of the angles.
Good. Then it's on the bisector of the angle. So this was all 5-1, just based on the angle bisector and the perpendicular bisector. It didn't have to be in a triangle, okay? So if it's on the perpendicular bisector, then it means it's equidistant from the endpoints and vice versa. And if it's on the angle bisector, then it's equidistant from the sides and then also vice versa. If it's equidistant from the sides, then it's on the angle bisector. So then the questions would have come like this, okay? Given that PS is 53.4, so this one is 53.4, and QT is 47.7, and QS is 53.4, find PQ. So why is it telling you that, why do you have two segments of the same? What would it be true because PS is congruent to QR? SQ. Good. It says that S is on the perpendicular bisector, which means what?
that they're congruent.
What's congruent?
So the
PS and QS.
PS and QS are congruent, and that's why it's the angle bisector, the perpendicular bisector. But if it's a perpendicular bisector, what's that tell you about what you're missing?
PT is congruent to TQ.
PT is congruent to TQ. Yes, that's correct. You see that? Yeah? Everybody understand that? So this would be 47.7. Because if these are congruent, then that's the perpendicular bisector, which means that T is the midpoint there. Danielle.
Isn't it asking for PQ like
Yeah.
Oh, I'm sorry. That's right. So I did that on purpose to see if you were paying attention. PT is 47.7. What would be PQ? Got to double it. Okay, so then 3 says, given that M is the perpendicular bisector of PQ, so now I know it's the perpendicular bisector. And SQ is 25.9. What would be SP? 25.9. Those two would be congruent because any point on the perpendicular bisector is equidistant from the endpoints. And then 4 says, given that M is the perpendicular bisector of PQ and PS is 4A, and QS is 2A plus 26. Find QS. How would I do it?
Set them equal to combine.
Good. Subtract the 2A. Divide by 2. And then it says QS, which means plug it back in. Take this and plug it back in. 2 times 13 plus 26.
52.
So that was all perpendicular bisector, and then 5 through 7 was angle bisector. Okay, it says that ray BD bisects ABC, which means that this is cut into two congruent angles, and CD is 21.9, which means AD is what? 21.9. Any point along the angle bisector is equidistant from the sides. Then it says, given that AD is 61 and CD is 61, so we didn't know that it was the perpendicular bisector this time. But if those are equidistant, then we know that it's the perpendicular or the angle bisector. And if ABC is 48, what's CBD?
Wouldn't it be 24?
24. It's half the 48. And then the last one here says that given that DA is congruent to DC, again, now it's telling you that that's the angle bisector. If DBC is 10y plus 3 and DBA is 8y plus 10, how would I find DBC? Good. Set them equal to each other. So this is 2y plus 3 equals 10. This is 7. Divide by 2. Y is 3.5 or 2 over 7, and then take it and plug it back in. Does it matter which one you plug it back into? No. Okay, I'm going to plug it back into DBC, but it doesn't matter because they should be the same. Questions on that? How many of you got all of those questions right and still remember why? That's the important part because this was 2 days ago, right? We have to then retain the information. Okay, Sophia?
Can you scroll up just like up to yeah. 'Cause I think I forgot.
Okay, then 5-2 is the perpendicular bisectors and angle bisectors now in a triangle. So the perpendicular, and see if you can do this off of memory instead of reading it. Perpendicular bisectors meet at a point called what?
Circumcenter.
Circumcenter. The point lies blank the triangle. In, on, and outside the triangle, right? In if it's acute. On if it's right. And outside if it's obtuse. The angle bisectors meet at a point called in center. And that point lies blank, the triangle. Always inside. The circumcenter theorem said that the circumcenter is good. Equidistance from the vertices. So from the circumcenter to each vertex would be congruent. The in-center theorem says that the in-center, good, equidistant from the sides. And remember, those will have the little perpendicular marks. All right, so the first one, these are angle bisectors. So I know, I'm going to zoom in on that one. Okay, and you had one a little bit like this on your quiz, right? This would be my in-center. These would be congruent. These would be congruent. Okay, and it's asking for the distance from F to CD. So F to CD, the distance from F to each side would be congruent, right? So if this is 42, then F to CD is also 42.1. 42.1. So from the in-center to the sides, or from where the angle bisector meets to the sides, are congruent.
Wait, that's for number. That's for number 2. Or 10.
No, number 9 says the distance from F to CD.
I thought 17.
It's not. 17 is the angle. But it's not asking for the angle. Number 9 is asking for the distance from F to CD, right?
It's the line.
So it's from the point where they meet to the sides. Angle, and I'm telling you right now, these are questions just like the ones on your test. So you've got to understand it. Angle FED, FED is this angle here, okay? So this is a lot like the quiz where I've got to get some angles to get to the others. If that top angle is 17, then so is this angle. So this is 34, good.
54 plus 34. Minus 1.
So 54 plus 34 is 88. Subtract that from 180. 92, that's this whole angle would be 92. Which means half of it would be?
46.
Good.
After 92, when you got 92, what did you do?
Then you have to cut it in half because 92 is the whole angle. So this whole thing is 92 and it's only asking for this angle in here. So you have to cut it in half.
How
did you get 92?
17 and 17 and then 54. Add those together. Subtract it from 180. You get the missing angle, which is 92. And then it wants half of that. So you got to cut it in half. So the final answer is 46. Yeah, let me do.
And those were both angle bisectors?
So the only piece of information that they gave you is that they're the angle bisectors. It could say they're the angle bisectors, or it could say F is the in-center, and you have to know that those both mean that from F to each side is congruent, and from F to each angle are bisectors, so each of them are cut in half. So from that information, if this is 17, then this is 17, and I need to find this angle so I can cut it in half to get what they're asking me for. So I would do 17 plus 17, which is 34, plus this 54. I get 88. Subtract that from 180. I get 92. That's this whole angle. So to get half, I would divide it by 2. And that's where your 46 comes into play.
Can you explain?
All right, SN, TN, and VN are perpendicular bisectors of triangle PQR. Find each length. So if they're perpendicular bisectors, this is a perpendicular bisector, this is a perpendicular bisector, and this is a perpendicular bisector. It means it hits each side at its midpoint. So this is congruent to this is congruent to this, and this is congruent to this. Everybody with me so far?
Yes.
And then the theorem about perpendicular bisectors tells me that from where they meet to what is congruent? From where the perpendicular bisectors meet, or from the circumcenter to?
The midpoint.
Nope.
Intersect.
Nope. In-center's not even perpendicular bisector, right? From the perpendicular bisectors to what are congruent? You just wrote it down.
The endpoints.
Nope. In a triangle. We're talking in a triangle.
Circumcenter.
From the vertices. The fact that 34 of you don't know that means you have a lot of work to do tonight, folks. From the point where the perpendicular bisectors meet, which is called the circumcenter, to each vertex is congruent. We've been saying this for a week and a half now. Which tells you that if PN is 5.64, what else is 5.64?
The other one.
What's the other one?
R and Q.
NR and QR, or QN. So NR we just said was 5.64 and QN is 5.64. And then RV is here. What would that equal?
5.47.
5.47 because it's at the midpoint, which means it's cut into two congruent parts. And TR is here, which means it's what?
3.95.
Good. So that's 2/3 of your test, 5.1 and 5.2. And then what you should hit on is 5.3. And this is what we talked about yesterday. All right, so again, this is what we talked about yesterday. The median, what's the median do? It connects two things. What are those two things? Okay.
Vertice to a side.
Good. Where on the side, though? Put your two brains together. Maybe we can get to this one thing. Ryan said the middle. What's the middle?
Midpoint.
The midpoint. Good. So we go from the vertex So the median goes from the vertex to the midpoint of the opposite side. The medians of a triangle meet at a point called, it's been 24 hours. Centroid. And this point lies blank the triangle. Inside. Medians and centroids always inside. And altitude is a segment that does what?
Isn't it on the centroid?
Nope, centroid is medians. So the altitude does what?
Finds the height.
The altitude is the height. It goes vertex to what? What about where it meets is important? Mm-mm.
Perpendicular circle from the vertex to the line containing the opposite side.
So the altitude goes vertex to the opposite side. It has to be perpendicular with the opposite side. So the vertex is the altitude is the only one that sometimes you have to extend the line out to even connect it to make it perpendicular. Which means that the altitudes lie where?
Outside, in, or on?
In, on, or outside. Same as your circumcenter, which is perpendicular bisectors. Okay, in would be acute, on would be right, and outside would be obtuse. What's it called where the altitudes meet? Orthocenter. And then there is no theorem about altitudes, but there is about medians, which says what?
But the orders were all the meet.
That's what they are. What did we learn yesterday that we haven't used yet?
Centroid of a triangle is located
2/3. This is the 2/3 rule, right? Okay, the centroid is 2/3.
precisely.
Yep.
You know, in the homework there was like I think it was 12 and.
So what you have to know about altitudes, one is that they're in on out, but two, also use the vertices to draw the altitude, which is what we did yesterday. So I'll get to that in a second. But this is all median based, right? How do you know those are medians? Does it say somewhere they're medians?
They go from the side, they go from the vertex to the midpoint.
Good. So they're not going to tell you necessarily, right? It might say these are medians. It might say W is the centroid, which means they're medians. Or you might have a diagram like this where they're all labeled as the vertex to the midpoint of the other side. So I know they're medians. So then if it says that WX is 204, and WV, oh, then WV is 408. Yeah, but what else does it tell you? It tells you that RW is 104.
Only XB is not 204?
Yeah, XB is 204.
That means what?
Oh, XV. I'm sorry. Okay, so the whole segment there is 204, right? Which part of that is a third of 204?
XW.
XW would be 1/3, which means WV is 2/3. So if I wanted to find what it asked for first, it asked for VW.
You have to multiply 204 by 2 divided by 3.
Good. So this is times 2/3. So I can multiply it first by 2. 204 times 2 is 408. And then divide it by 3.
136.
So that would be this section.
I'm going to subtract 204 from 136 to get WX.
So you can either do the 204 times a third, right? Or do the 204 minus 136 to find
And
that.
then XW would be 60.
This is 68. So you could either divide 204 by 3, or you could just subtract what's left. So VW is what we found first is 136. WX is 68.
So those are the only two ways you can figure it out?
Yeah.
What?
I mean, you have to basically take your segment and divide it into thirds. And
Where did you
the,
get 403? Oh, I see. 408.
okay. And then the other part is based on the green segment.
'Cause WX was 24, right?
WX is 68. So RW is 104. This time they didn't give you the whole segment. What part of that segment did they give you? The 1/3 or the 2/3? The 2/3. So I cut it in half to get the other 1/3, right? Half of 104 would be 52. This is 52. And then I can add those together to get the whole thing.
Oh.
Wait, how did you get 52?
It's half of 104. So I got given the 104. The 104 is the 2/3. To get 1/3, I just cut it in half. Okay, and then this is the deal with the orthocenter. So we said the orthocenter, we would be plotting points and finding orthocenter is the altitude, right? So if I start with 2, -2, and I go to 4, 6, thank you, and 8, -2. And I draw my triangle. Now I have to go from each vertex to the opposite side where a right angle would hit. So So I'm going to leave it this way first because it's nice and flat in the bottom, and I'm going to drop a line straight down that would be perpendicular to the bottom. If you remember slope, the other way that we can do this is the, excuse me, the segments that are perpendicular have to have opposite reciprocal slope. So the other thing I can do, if I can't figure out where it would be perpendicular, is to calculate the slope of each line and then find the opposite reciprocal. Use a point on that line and count my slope so that it's perpendicular.
Are you gonna have this in a class?
Why do you think I'm going over it? So perpendicular here would be about here. And then I'd rotate it again. And then I'd find the point where they meet. Yep. Again, I'm not going to give you an obtuse one. You'll get an acute or you'll get a right.
Okay.
Or you won't get obtuse. So this is 1, 2, 3, 4 over 4 and down halfway, so negative 1/2. I'll do those other 3 examples. And I posted a review. It's the one from your book. So use your book to get your answers. So for the first one, it was actually the same for both quizzes. Okay, it said that PQ is the perpendicular bisector of MN, which means that any point from PQ to the endpoints of MN would be congruent. To do that, you had to set 6x plus 1 equal to 10x minus 17. That work is there. And you should have gotten x equals 4.5. Some of you saw 4.5, got excited, circled your answer, moved on. What was wrong with 4.5?
Plug it in.
It said, what is MN? So be careful and read your instructions. I gave you half credit, but technically in a multiple choice, that would have been all credit lost. Be careful, okay? So it said MN, which means you then have to take the 4.5 and plug it back in, and you could plug it back into either of the 6x plus 1 or the 10x minus 17. Oh, no, sorry, it asked for MN. So you had to plug it into MQ here, and you would have gotten 14, and then it wanted MN, which does the whole side, so you had to double it to get to the 28. Braylon.
So when you got 4.5, you plugged it in 2x plus 5?
Because it asked for MN, which is that left side, so I plugged it in the 2x plus 5, but that's only half of that side. I had to then double it to get the whole side. 2 said that this is the, well, it was marked as congruent here and here, which tells you that that's the angle bisector. So MLK was cut into 2 congruent parts. It gave you LJK was 35. So if this is 35, that's 2 separate right triangles. Subtract the 35 from 90, and you get 55 for this angle. And then again, some of you saw 55, got excited, circle 55. But it asked for MLK, which is that whole angle. So you had to do 55 times 2, and you got 110. Yep.
How did you get 55 for the...
So this triangle here,
Oh, you did 90 minus 35.
exactly. You're not even looking at it. 4 is talking about the circumcenter. So the circumcenter is where what type of segments meet? And one wrong on your test already. Good job, folks. The circumcenter is where what segments meet? Perpendicular bisectors. So the perpendicular bisectors, which are each of these little perpendicular segments, this one and this one.
They meet at Z, which is on 5.
Exactly. That one. They meet at Z. The 5 is ZR, right? So then what we know about the circumcenter is that from the circumcenter to each vertex is the same. So this segment is congruent to this segment is congruent to this segment. So when it asks for what TZ is, because ZR is 5, TZ is also 5. How do I know what?
Oh, there was a 5 right there.
Yep.
I see.
Okay, some of these questions were different. So one of them said this: the in-center of the triangle is always inside the triangle. That is true. In-center, always inside. Okay. On the other quiz, it said the circumcenter is always outside the triangle. That's false. Where does the circumcenter lie?
Inside.
In, on, or outside. Circumcenter's in, on, out. In-center's always in. Number 6 said the perpendicular bisectors of a right triangle are located on the triangle. So perpendicular bisectors are your in, on, out. In for acute, on for right, and out for obtuse. This one said the angle bisectors of an acute triangle are located and they're always inside. So again, you've got to know that vocab to know that stuff. Okay, and then this one, 2 different values, but still the same method. So it said K is the in-center of PQR. The in-center is where what type of segments meet? The in-center is where what type of segments meet? Nope, you just said circumcenter was that. Angle bisector. So that told me that each of these angles were bisected. That would equal that, that would equal that. And this one, if it was bisected, would have been cut in half.
Why would it be 35 and 35?
So I'm getting there. This was 30, right? Which means this is 30. You with me on so far?
Yeah.
So then I have one big triangle here with 3 big angles. This is 50. This one would be 60 if you add those 2 together. And then this whole angle would be 180 minus 50 minus 60. So if I add this is 110,
70.
180 minus 110, 70. That's the whole angle here. So you had to cut it in half to get the 35 and the 35.
I have a different one.
Yeah, you have the different number, but it ends up being the same because you would have gotten 20. And then on the left, I'm sorry?
You have the other one?
Yeah, I'll go to it in a second. I'm not done with this one yet. And then it asks for RKQ, which is this angle here, which is the other thing you guys struggle with. Like, what does that mean? RKQ goes in that order. RKQ is that top angle. So if this one was 35 and this one is 30, I just add those 2 together. I get 65, subtract it from 180, and I get 115. So there was a lot of steps involved there, but the individual steps you should know well. You've got to know the angle bisectors, or the in-center means angle bisectors, which means those angles are cut in half. The other one,
I had that one, but you said it was 110.
no, 115. So this time it gave you this was 20, right? So if this is 20, this is 20. This big angle would be 40. This is still 50. So if I add those together, I get 90. Subtract it from 180. This would have been 90. Cut it into 2 congruent parts, and I get 45 and 45. So then the top angle would be 180 minus the 45 and the 20 that were given to you from the other 2 angles, which is 180 minus 65, which is 115.
So you did 40 plus 50 minus 100.
Yeah, and that gave you the left angle, and then you had to cut that into 2 parts, 45 and 45, and then you've got the small triangle inside there. Okay, and then number 8, the circumcenter of the triangle. So you had to find the midpoint of each side, and then just draw a perpendicular line straight up and down. So for one test, or one quiz, it was this one. This is 4 units, and you're going to get a question just like this on your test tomorrow, so make sure you know how to do it. Okay, you're actually going to have to graph it. So you're going to graph it. You're going to find the midpoint, draw a vertical line. You're going to count over here, find the midpoint, draw a horizontal line that time, and where they meet, which is 1, 2, 3, 1, 2, 3, 4. And you would do the same thing on the other version. So this time I would find the distance between these, count the midpoint, go up and down, count the distance here, find the midpoint, go side to side, and where they meet is your circumcenter. So there's 2 coordinate, well, not 2 coordinate, I think there's 4 coordinate questions, but 2 coordinate type of questions. One is the circumcenter, which is like that, and one is the orthocenter, which is what we talked about yesterday.
Wait, can you like the other one?
The first one?
Left one?
Or the left one?
How's that?